afternoon, everyone. So, my name is Thierry Chevalier. Actually, I am a software engineer with a specialty in web GIS, for which I'm doing training in software design, which are quite different activities anyway. But, I've been mainly involved in not so much in archaeological projects actually, but mainly in cultural inventories and also for projects for geological surveys. But in the context of providing trainings, I realized that the tools and technologies that were used by the different communities were somehow the same. I'm not a 100% computer geek anyway. I'm also a student in ancient history. And then I would like to just split my presentation in two parts because the first part was free and open source geospatial software. And I would like to talk to you about a conference which is actually taking place every year. I don't know if you have heard about it, but it's a free and open source software for geospatial conference, which is an annual recurring global event hosted by the open source geo community. And if you're into the mood of contributing to open source projects, and if you have a low budget, for instance, for your projects, I really suggest you strongly to attend this kind of event because this is really extremely interesting. So what is the OSGeo? It is a not-for-profit software foundation devoted to the open philosophy at large. So the OSGeo just maintains some projects that you have probably heard about some, probably not all of them. But then you could see you've got content management systems, you've got catalog for geodata, you've got desktop applications and web mapping facilities. So when you're trying to say, okay, we'll be using open source geospatial software, and you come to this page and say, okay, but where should I start? So my personal advice on this, it would be for you to start on GDAL and OGR. For what reason? Because this is a geospatial library which allows you to perform reprojections and format conversion. And why is this so important is because when you go to, I don't know if you know the Stack Exchange, probably if you've got a problem in web development somehow, and it's particularly the case in WebGIS, if you ask Google, then Google asks GIS Stack Exchange. And one of the main topics about this is about coordinate systems. It's really something people struggle with. And the other main topic is about the raster data format. And GDAL allows you to perform all this. So then it was to start, but then what should you learn in second way? Well, I would say it's up to you, it's up to your needs and so on, but mainly if you deal with raster data, for instance, I would just talk to you about QGIS, and if you deal with vector data, I would talk to you about PostGIS. So PostGIS is a spatial database, which is perfectly fine for hosting and for developing handling vector data. So in the second part, I would like to talk to you about archaeology open data. Well, what are open data? Data that are accessible online, which are openly licensed. For instance, Creative Commons by, which means that you provide credit from the original author, reusable and free. And then for archaeology, open data means something quite specific because we have repositories which are dedicated to archaeology data. So there are plenty of them, but I only mentioned one, which is the Archaeology Data Service, because it's probably the most important. You've got platforms providing access to referencing these repositories about the area, and then you have got data papers, so the Journal of Open Archaeology Data. So, as researchers, why would you provide open data access? Why would you open your data? So actually it's a matter of recognition, and in the beginning, it's all about reuse. So if there is no data reuse, there will not be citation of your data and no recognition. So that's basically what the data papers are about. So for instance, the Archaeology Data Journal, I don't know if you come to this website, but when you push some data on it, then it provides statistics about download, citation, and so on, so that you could have recognition about it. But then, and this is the point of this presentation, it's if there is no perception of the potential of your data, then there will be no data reuse. And so comes the solution from the FOSS4G to make people perceive the potential of your data. So we propose you here a solution based on PostGIS and CartoDB, which is a solution built on top of PostGIS. So what I've been using here is an open data set, which is the cultural evolution of Neolithic Europe, which is named EuroEvol, and which is a data set by Katie Manning and the UCL team. And it is the largest repository of archaeological site and radiocarbon data from Neolithic Europe, with about 4,000 radiocarbon samples. And then, this is basically the visualization you get from this data. So, but how could you get the potential of this data set based only on this kind of map is quite difficult to assess. But it's perfectly fine, because for open data, you need to open the access to the raw data. That's very important. But then you could also add visualization tools in order for the people to evaluate correctly the potential of your data set. So that's, for this I will be showing you a small video. So using CartoDB, which is built on top of PostGIS. This is an open source solution. So we'll move on a bit. So which allows in really a couple of clicks to upload the data set. So we move a bit forward here. Okay, so you've uploaded your data set, and then on this basis, you could, using PostGIS functions, for which there is an API on top of it, which is provided by Carto, and which allows you to, for instance, add widgets. That means filters on this data set. For instance, based on the different attributes you've got. For instance, the materials. So what are the radiocarbon samples? Is this charcoal, bones, wood, etc.? So you could add a filter on this input, for instance. So if you click on one thing, you will have a filter on bones data, or on wood, if you prefer. That is to say, the sites where these materials have been found. And then you could add different widget to it. So you could, for instance, add another filter for instance, a period. It might be interesting to filter this data set on a period. So then you select the period information. And then you've got the different values. Here are only the main values. For instance, where are the sites where we have found materials dating from the late Neolithic or from the Bronze Age, for instance. So you see that mainly in this case. And you could add all the filters you want regarding your attribute data. What is interesting as well is that you could add temporal filters. So here we could have, for instance, the radiocarbon age, which would be a very interesting filter to have on this data. So here it allows you to filter also on a time span, for instance. So you can play with the duration bucket, and then, for instance, filter on a dedicated period. For instance, here between 4,500 and 3,300, and then you will have a filter on your data based on this. And then you could also animate this data, because this is a dynamic phenomenon, and then you could For instance, just add this when you publish it. So you could have this kind of animated view of where are the findings according to, according to the samples. So this is this kind of view that you could have with actually PostGIS. So this is very simple to put in place. Sorry. And then what I would like to talk to you now is not only the open philosophy in geospatial brings open source libraries and applications, but also a complete open source map of the world, and which is OpenStreetMap, you maybe know. So what is interesting with this project here, I would like to talk to you about a very specific thing, is there is a company which has decided to contribute to OpenStreetMap and then provide some new facilities, open source things to this, and it is the technology of vector tiles. So I would like to talk to you a bit about vector tiles, because until now we had on the web browser raster tiles, which means that at a different zoom level you had different squares corresponding to different images, and which are sent to you by the server and calculated and put in cache. So the difference with raster tiles in this case is that rather than sending images, the server sends vector data. So it is not actually text, but kind of binary data. And what does it change? It changes the fact that the rendering is not made on the server side, but the rendering is made on the client side. So that changes a lot, because you don't have to recreate a whole tile set when you want to change a little thing in your map. So for instance, let's say you want to change the size of the country names, or let's say the color of the forest or the sea or so on. You can do it on the browser side without changing anything on the server side. So one of the potential of vector tiles in archaeology is, according to me, when you have to map changing environments. So for instance, there is a problem of sea level in paleo environments. So I guess that in the future years it will be much easier to build sleepy maps, which means vector tile sets, for maps with different sea levels according to the use. So, well, the only thing missing for the time being is just a bathymetric vector tile set, which is, I know that Mapbox had worked on open source of open vector tile set for the terrain, well, but unfortunately there are not bathymetric data. So that does not allow us to build a map for, let's say, the Ice Age era, but I'm pretty sure it will be the case in the next year. So this is very promising technology. So, and I would like to end it with my presentation with this aspect. So when we talk about open source projects, something that you might think about is, which open source should I contribute to, or could I contribute to, in order to give back what I gained for this project. So, well, at least I would advocate the thing I'm contributing to is just OpenStreetMap, and particularly OpenStreetMap and cultural heritage. So, because I made two observations, not the one who made them, but everyone could make them. It's just that the location is the linking pin for every cultural heritage data, and that the potential of OpenStreetMap for cultural heritage has not yet been explored. You would be very surprised to see and to discover how many contributors of OpenStreetMap there are even in your surroundings, and in this very large community, which is over a million of persons. There are of course people interested in culture. So there is an initiative that are started at least in France, which is to start to map the if you see it, the indoor location of artifacts in museum collections. Sorry, it's not working, so I need to switch here. So if you go to OpenStreetMap and then try to, for instance, look for the Louvre Museum, then if you're not authentified, then you will only see the buildings. So you might think OpenStreetMap is only about the outside of buildings, but actually it's not. And if you go into, if you enter into the edit mode, then you will see that when you contribute, you enter into this mode, you will see that actually the inside of buildings is also mapped. And you've got all the artifacts, or a lot of them, in the collection of the Louvre. So for instance here you could see the locations of, let's say, this is the Egyptian collection. So here you have a mummy mask with a lot of metadata, which is specifying what it is about, dynasty, ancient Egyptians, and what is interesting is you've got the origin as well. So you could link it to somehow archaeological data, or at least excavation sites or location where the artifact has been found. So, and this is the case for a lot of data in the Louvre. So obviously this representation is not adapted to inside the indoor locations. But there are some initiatives as well in OpenStreetMap community to provide visualization and contribution tool for indoor locations. So that was an insight about something to contribute to if you want. So that's it for me. Oops, sorry. No, that's not this one. So thank you very much.